Scientists studying the largest glacier on Earth have started using two words they almost never use, any day now. The floating ice shelf holding back Antarctica's infamous Doomsday Glacier is rapidly breaking apart. For years, scientists believed its collapse was decades away. But now, after analyzing over 20 years of satellite images, GPS measurements, and ice movement, many researchers believe the shelf could fail this year, or even at any moment. At first, that may not sound terrifying. After all, it's just a floating slab of ice. But what makes this story so alarming isn't the shelf itself. It's what the shelf is preventing. In the next few minutes, you'll discover why scientists are watching this glacier more closely than almost anything else on Earth, and why one crack in Antarctica could eventually reshape coastlines across the entire planet. The glacier at the center of this story is Thwaites Glacier, located in West Antarctica. Scientists call it the Doomsday Glacier for one simple reason. It has the potential to trigger one of the largest sea level rises in human history. Thwaites is the widest glacier on Earth, stretching nearly 120 kilometers across, roughly the size of Florida or Great Britain. In some places, it's almost 2 kilometers thick, a massive wall of ice containing unimaginable amounts of frozen water. Holding back part of this enormous glacier is a floating platform known as the Eastern Ice Shelf. Think of it as a giant natural dam. It doesn't stop the glacier completely, but it slows its movement toward the ocean. Scientists often compare it to a cork in a bottle or the brakes on a speeding truck. As long as the shelf stays intact, the glacier behind it moves much more slowly. But there's one shocking detail most people don't know. This entire floating shelf is being held in place by one small anchoring point on the ocean floor. Deep beneath the ice, a rocky underwater ridge catches the bottom of the shelf, preventing it from drifting away. Imagine a structure the size of an entire state depending on a single hook to stay attached. That tiny connection has been carrying an incredible amount of pressure for decades. And now, it's beginning to fail. Over the past 20 years, scientists have watched huge cracks spread through the shelf's weakest area, known as the shear zone. Using satellites, GPS stations placed directly on the ice, and detailed measurements of glacier movement, they've tracked these fractures growing larger every single year. The cracks aren't random. They're spreading directly through the section that keeps the shelf connected to its underwater anchor. Recent studies published in 2025 revealed that both the surface and the underside of the shelf are now heavily fractured. Large sections are already pulling away from the main glacier. Researchers no longer ask if the shelf will collapse. They're asking when. Some scientists estimate it could happen within the next 5 years. Others believe the breakup could begin as early as this year. That change in confidence is what has captured worldwide attention. Because once this natural break disappears, the real danger finally begins. Before we go any further, it's important to clear up one common misunderstanding. If the Eastern Ice Shelf breaks apart tomorrow, global sea level will not suddenly rise overnight. Because the shelf is already floating. Just like ice cubes melting in a glass, floating ice already displaces its own weight in water. Whether it melts or shatters, the water level barely changes. So if that's true, why are scientists so worried? Because the shelf has never been the real threat. The shelf is simply the break. The glacier behind it is the danger. Unlike the floating shelf, Thwaites Glacier is resting on land. It's locked onto the Antarctic continent, storing an enormous amount of ice. As long as the shelf pushes back against it, the glacier flows into the ocean relatively slowly. But remove that support, and a glacier the size of a country begins moving much faster toward the sea. That acceleration is what concerns scientists. Even more worrying is that once this process starts, it becomes incredibly difficult to stop. Ice sheets respond slowly, meaning the consequences continue for decades, or even centuries, even if global temperatures stopped rising tomorrow. So the shelf's collapse isn't the disaster itself. It's the starting signal for a much larger chain reaction. But why is that anchor point failing in the first place? The answer lies somewhere almost no one can see. Beneath Antarctica, warm ocean water is quietly flowing underneath the ice. This isn't warm surface water. It's a deeper layer of salty water that travels along the ocean floor. Because much of West Antarctica sits below sea level, this water can reach far beneath the glacier, melting it from underneath. That's the key difference. The attack isn't coming from above. It's coming from below. Year after year, that warmer water slowly melts the glacier exactly where it touches the seabed, weakening the very point holding the shelf in place. Scientists say this underwater melting is one of the biggest reasons the shelf is now losing its grip. And this isn't happening by chance. Earth's oceans absorb around 90% of the extra heat trapped by greenhouse gases. Since oceans cover more than 70% of the planet, they store enormous amounts of energy. Some of that heat is now reaching Antarctica's most vulnerable glaciers. The evidence isn't limited to Antarctica either. Over the last several decades, scientists have found that rising ocean temperatures and the melting of land ice have become the biggest drivers of global sea level rise. The ocean isn't just recording climate change. It's actively reshaping the world's largest glaciers. Which raises another question. How do scientists even know what's hidden beneath kilometers of Antarctic ice? For decades, the landscape under Antarctica remained one of the least understood places on Earth. But that changed recently. In 2025, researchers released the most detailed map ever created of Antarctica's hidden bedrock. And what they discovered made the situation even more alarming. The new map, known as BedMap 3, combined more than 60 years of research, including satellite observations, aircraft radar surveys, ships, and millions of underground measurements. For the first time, scientists could clearly see the hidden landscape beneath Antarctica's massive ice sheet. And what they found changed everything. Much of East Antarctica rests on bedrock above sea level, making it relatively stable. But West Antarctica is completely different. Large parts of it lie far below sea level, forming enormous bowl-shaped basins hidden beneath the ice. Thwaites Glacier sits directly inside one of the deepest of these basins. That shape creates a dangerous weakness. It allows warm ocean water to travel deep beneath the glacier, melting it from below and weakening the places where the ice is anchored to the seabed. As scientists improved their maps and climate models, something unexpected happened. Instead of reducing uncertainty, the new data revealed even more pathways for instability. In other words, the clearer the picture became, the more serious the threat looked. But the story doesn't end with one glacier. Thwaites is considered the keystone of West Antarctica. Think of an old stone arch. Remove one ordinary stone, and nothing happens. Remove the keystone at the top, and the entire arch begins to collapse. Scientists believe Thwaites plays a similar role. It helps support several neighboring glaciers, including Pine Island Glacier, one of the fastest changing glaciers on Earth. If Thwaites retreats far enough, it could reduce the stability of those glaciers as well. Instead of one glacier accelerating toward the ocean, several major glaciers could begin moving at the same time. This is why researchers pay such close attention to Thwaites. It's not just about one glacier. It's about an entire region of Antarctica. Scientists even have a name for the process they fear most: marine ice sheet instability. Here's how it works. As the glacier retreats inland, it moves into deeper parts of the basin. Deeper water allows thicker ice to reach the ocean. Thicker ice flows faster. That faster movement causes even more retreat, which exposes even thicker ice, creating a powerful feedback loop that keeps accelerating itself. It's like pushing a massive boulder over the edge of a hill. The hardest part is the first push. After that, gravity does the rest. Researchers have already detected thinning extending nearly 100 kilometers inland, suggesting this process may already be underway. And if that's true, the glacier could continue accelerating for decades, becoming increasingly difficult to slow down. The frightening part isn't just what scientists predict. It's that they're already watching the early stages happen in real time. In 2026, another major study gave scientists an even clearer picture of what could happen next. Using two independent ice sheet models, researchers recreated how Thwaites changed between 2004 and 2017. Once the models accurately matched real-world observations, they projected the glacier's future. The results were alarming. By the 2060s, Thwaites could lose around 180 to 200 billion tons of ice every year. To understand how massive that is, that's close to the amount of ice the entire Antarctic ice sheet loses today, coming from just one glacier. But perhaps the most unsettling discovery wasn't the number itself. It was which models produced it. Normally, scientists treat the worst-case models with caution. But in this case, the models that matched real observations most accurately were also the ones predicting the greatest future ice loss. In other words, the better the model matched reality, the worse the future looked. That gave researchers much greater confidence that this isn't an exaggerated scenario. It's a warning based on observations collected over decades. So what does all of this actually mean for the rest of us? The answer comes down to one number: sea level. By itself, Thwaites Glacier contains enough ice to raise global sea levels by about 65 centimeters, or just over 2 feet, if it were eventually lost. That alone would permanently reshape coastlines around the world. But Thwaites is far more dangerous because it's connected to the larger West Antarctic ice sheet. If enough neighboring glaciers become unstable, the total long-term sea level rise could approach 3 meters, or nearly 10 feet. That amount of water would dramatically change some of the world's biggest coastal cities. Places like New York, Miami, London, Shanghai, and Tokyo would face increasing flooding, expensive sea defenses, and in many areas, the gradual relocation of millions of people. Low-lying countries such as Bangladesh would face even greater risks. Scientists estimate that, over time, hundreds of millions of people could be affected by rising seas if these long-term changes continue. This doesn't happen overnight. It unfolds across decades. But once the process gains momentum, stopping it becomes incredibly difficult. And that's exactly why researchers are paying such close attention to one glacier at the bottom of the world. So let's be clear about what this does and doesn't mean. This is not the end of the world next week. Even if Thwaites eventually collapses, a glacier this enormous cannot empty into the ocean overnight. The full process would unfold over decades or even centuries. Anyone claiming that coastlines will disappear next month is exaggerating the science. But the opposite mistake is just as dangerous: ignoring the warning because the effects take time. The event scientists believe could happen soon is the breakup of the eastern ice shelf, the floating platform acting as the glacier's natural break. When that shelf finally breaks away, sea levels won't suddenly rise that day. But it could mark the moment when the world's most dangerous glacier begins moving faster toward the ocean. What makes this warning different is that it isn't based on just one study. Several independent lines of evidence now point in the same direction. Detailed satellite observations show that the shelf has been weakening for more than 20 years. The latest Antarctic bedrock maps reveal hidden basins that allow warm ocean water to reach the glacier from below. Ocean measurements confirm that warming seas are delivering more heat beneath West Antarctica. And modern ice sheet models, tested against real-world observations, predict increasingly rapid ice loss in the decades ahead. Each piece of evidence tells part of the story. Together, they paint one clear picture. Scientists aren't worried because of a single dramatic photograph or one unusual season. They're worried because every new measurement is reinforcing the same conclusion. Antarctica may seem unimaginably far away, but the oceans connect every coastline on Earth. What begins as a crack in a floating slab of ice thousands of miles from civilization can eventually influence cities, ports, beaches, and communities across the globe. That's why researchers continue monitoring Thwaites Glacier almost every day. Not because disaster is guaranteed tomorrow, but because the decisions we make and the warnings we pay attention to are often most important before the biggest changes begin. Sometimes the most dangerous events don't arrive with an explosion. They begin quietly, with a crack that almost nobody notices, until it's too late.